Okay, so just for a bit of an introduction, my name is Abhijyot Chadha. I'm a sophomore in high school going into my junior year. And here's a problem given to us. Compute the number of 5-digit positive numbers whose digits are non-increasing left to right. So let's start with this example, which has the number 87,741. So what makes this number non-increasing is that every digit either goes down from left to right, so how 8 is going to 7, that's -1, or every digit is has no change. So this is -0. This would be -3, this would be -3. And since all of these are minuses, the number is non-increasing. Okay, so how can we count these? Well, let's let the digits of our number be A, B, C, D, E, which we'll denote by the number, which in case you don't know, this top bar just means that this is one integer. It's not A times B times C times D times E. It's the number with digits A, B, C, D, E. That's the notation I'm going to be using from now on. Okay, moving on from that, we have that for this number to be non-increasing, A is greater than or equal to B is greater than or equal to C is greater than or equal to D is greater than or equal to E. Okay, now let's first do this. Let's add 4 to A. So now A plus 4 is greater than B, C, D, E. Now let's add 3 to B. It's still greater than B plus 3 because we're adding 4 and adding 3 here. So subtracting 3 from both sides will give us A plus 1 is greater than B. And if we do this for all C and D and, well, E is going to get a +0, so we'll write it as E. We have this new inequality. And recall that from earlier, all our digits are less than or equal to 9, because if it was equal to 10, it wouldn't be a digit anymore. And so A plus 4 will be less than or equal to 9 plus 4 is equal to 13. There we go. That means all our digits here are strictly distinct, and they're elements of the set are elements of. This symbol just means they're elements of some set, and that set is defined as 0, 1, 2, 3, on and on and on until you reach until we reach 13. And once we choose our 5 elements from this set, what we can do is from our greatest element we subtract 4 to get A, next element subtract 3 to get B, subtract 2 to get C, and subtract 1 to get D, and then our last element will be E. Also notice that since our final product is going to have numbers which are non-increasing, if we can find numbers satisfying our new constraint, then we'll have a unique non-increasing number. So now we have to figure out how can we choose our numbers from this. Also, sorry, this should not be A through E. This should be A plus 4, B plus 3, on and on and on until E. Okay, well now, how can we choose these numbers? Well, a fast way of doing this would be something called choose notation. 14 choose 5. And in case you don't know what this notation is, 14 choose 5 is essentially equal to 14 factorial over 5 factorial times 14 minus 5 factorial. And in general, we have that n choose k is equal to n factorial over k factorial times n minus k factorial. And now, essentially what we have here is that if we solve this expression, we'll get that 14 choose 5 is equal to 14 times 13 times 12 times 11 times 10 over 5 times 4 times 3 times 2 times 1 is equal to 2002. But wait, we almost forgot something important. Notice that when A is equal to B is equal to C is equal to D is equal to E is equal to 0, so we have A equals B equals C equals D equals E equals 0. Our final number is going to be 0, 0, 0, 0, 0, which is not a 5-digit number. So we have to subtract 1 for that. And this will give us our final answer of 2001. Just a quick brief remark. I know I sort of skimmed over this part. The reason why, if we choose like, let C, D, and E equal to 0, but A and B are not equal to 0, what happens is that since B is not 0 and B is greater than or equal to C, our number is going to start with something other than 0. Like, for example, let's say B, C, D, and E are all 0. Okay, so now we have some number of this form. If A is greater than B, by default, A is not equal to 0. And thus we have some unique number for some value A. And that we can use the same logic for B, C, D, and E. And the only case when this isn't a number is when all the digits are zeros, which we counted here for our final answer of 2001.